Okay, so today we're going to look at secant, cosecant, and cotangent functions. And then we are also going to look at some more transformations. First of all, cosecant function. Now, these are in your book, but I want to go over them, discuss them, so I'm going to show you the specific graphs of them. If you want to graph them, that's up to you. So if you want to put them on graph so you can see it, then you can do that, but I'm going to go ahead and do them up here. Upper right, Geo, right there. So, in making the graphs of these functions, first of all, a reminder that cosecant is the reciprocal of sine. So the first thing we want to do is we want to make the graph of sine. So we're going to do everything just like we did when we were making them before. So I'm going to label my graph the same. As I did when I was looking at sine, cosine, and tangent. You can go by halves if you want for the y's. Doesn't really matter. But when you're done labeling your axes, then draw the graph of sine as a dotted line. Okay, so after you get it, the axis done, then draw the graph of sine as a dotted line. Okay, so with a graph of cosecant, because it's the reciprocal of sine, that means we're going to look at the values of sine and take the reciprocal of them. So let's start with our main values that we work with for just drawing the graph to make a good rough sketch. So at 0, sine is 0. What's the reciprocal of 0? No, it's not. The reciprocal of 0 is undefined. So where sine equals 0, cosecant has a vertical asymptote. Where sine equals 0, cosecant is undefined, so it has a vertical asymptote. All right, let's take our other values. What's the reciprocal of 1? 1. What's the reciprocal of -1? Okay, so at pi over 2, cosecant is 1. At 3 pi over 2, it's negative 1. Okay. Now, it's the other numbers where we have to work with. So when we were first drawing sine out, we were looking at 30, 60, 90, or pi over 6, pi over 3, pi over 2 were the numbers we were looking at. So if we look at our unit circle, what is the sine of pi over 6? Okay, it's 1/2. And the reciprocal of 1/2 is 2. So at pi over 6, which would be here, sine equals 2, or cosecant equals 2. Okay. All right. So at pi over 3, sine was the square root of 3 over 2, right? Okay. So let's take the reciprocal of that. What's 2 divided by the square root of 3? Give me a decimal number in this case. That square root of 3 over 2 is 0.866. What is it? 1.154. Okay, so that's just going to be about here then. All right. And if we go to 2 pi over 3 and to 5 pi over 6, we're going to get those same numbers that we had. And so this graph looks like this. So it looks like a U. Then between pi and 2 pi, we get the same results except for what? Okay. It's frowning. It's in the negative. So it's going to look like this. So there's our graph of cosecant. All right, so we need to talk about domain and range for this graph then. So what is the domain for the graph of cosecant? Okay, our angle is t, so t cannot equal what? Pi n would be correct. Where n is an integer. Okay, so any form of pi and it does not exist, we have a vertical asymptote, so t cannot equal that. How about the range then? What about the values of f of t or y? Okay, so f of t is greater than or equal to 1. Do I put or and? It's or, because it can't be both at the same time, right? Or f of t is less than or equal to negative 1. Okay, it's or because it can't be both of them at the same time. So how do you think the graph of secant is going to be compared to that? Okay, all right. going to look just like it, but what happened with cosine and sine? It was just a horizontal shift, right? So for secant and cosecant, then it's just going to be a horizontal shift. All right. So then draw the graph of secant, yes. The period is, okay, we didn't mention that, so let's talk about that then. What is the period for this function? How often does it take to repeat itself? Well, there's a section in the numerator, or above the x-axis here, right? And a section below the x-axis here. Are those things the same? No, they're not. So that whole thing needs to repeat. So that would be, the period would be 2 pi, just like sine. All right. And so then you go ahead and do the graph of secant. Okay, so the same thing, we're going to be doing reciprocals. So think of it as the same reciprocals then. So wherever cosine equals 0, then secant is undefined. Did I mess that? No, I can't do that. Well, then we keep going. So what is our domain then for secant? T cannot equal to, according to Maria, pi over 2 plus pi n. What do you think? Is that right? Okay. All right. Good job, Maria. Where n is an integer. WNIAI. Yes, you do. When you would lose a point. No. Okay, the range then. What's the range here then? Okay, greater than or equal to positive 1, less than or equal to negative 1. What's that? And the period is 2 pi. Is that better? Allie? Just that when you're doing it a lot, then it's easier just to put a line over it. Not that I can't do it, I just choose not to. Okay? All right. Transformations of secant and cosecant then. Now, we're going to do cotangent after this. Okay? So, all of our values are still the same. We're still talking about f of t equals c times f of a times t minus b plus d. Okay? There's still our transformations. C, if it's negative, is a vertical reflection. If it's greater than 1, it's a stretch. Less than, between 0 and 1, it's a compression. Okay? A is a horizontal stretch or compression. So it is the reciprocal. If it's negative, it's a horizontal reflection across the y-axis. If A is greater than 1, it's a compression by the reciprocal, by 1 over A. If it's between 0 and 1, then it's a stretch by the reciprocal of 1 over A. If B is positive, it goes to the right. If B is negative, it moves to the left. If D is positive, it goes up. If D is negative, it goes down. Okay? Big thing to always remember is that this, if it's sine, cosine, tangent, cotangent, cosecant, secant, parentheses, t plus or minus something, that's horizontal. If it is a number in front of sine, cosine, tangent, cosecant, secant, cotangent, it's a vertical stretch or compression. And if I add something on to the end of the whole thing or subtract it, then that is a vertical shift. So when we look at number 1, it says negative 3 cosecant of t. What letters does that negative 3 represent? A, B, C, or D? C. So because 3 is greater than 1, or the absolute value of it's greater than 1, this is going to be a vertical stretch and reflection. Easiest way to do it, to graph it, would be what? Calculator. Well, that'd be one way we could do it, but there's easier way than the calculator even. Okay? Shelby, what would we do? Okay? Take all of your specific y values, that your important y values, and multiply them by negative 3. Okay? So, first of all, let's set this up. We're going to go from negative 2 pi to 2 pi. So we've got negative pi here, 2 pi there. Oops, that's positive pi. Negative pi here, and negative 2 pi over there. Now, cosecant is undefined when sine equals 0, right? Okay. So, that's where we're going to have vertical asymptotes. If I'm multiplying by negative 3, my y values, is that going to change where the asymptotes are? No, it's not. So I can go ahead and put those asymptotes in there. At 0 and any form of pi. Okay. Sine is 1 at pi over 2. So if I take 1 and multiply it by negative 3, we get negative 3. So we're going to be at negative 3 at pi over 2. Now, the other number we used was at pi over 6, right? At pi over 6, secant was equal to, okay, it was equal to 2, right? And 2 times negative 3 is negative 6. So we're going to be reasonably close to our asymptote there, reasonably close to the asymptote at pi, and then we draw our graph. Oh, that's nice and chubby. And then we go the other way with it. Close to that. Okay, so there's a graph of negative 3 cosecant of t. All right, so this graph, if I describe the transformation, so this has a vertical reflection and a vertical stretch by a factor of 3. Okay. Number 2 says 3 secant of t plus 2. All right, the 3 refers to what number? C. Okay, so that means we're going to stretch this one by a factor of 3 also. Okay, but what about that plus 2 on the end? What does that tell me? Okay, we're going to vertical shift up 2. So we have a vertical stretch by a factor of 3 and a vertical shift up 2. Now, is there any horizontal movement here? No, there's no change horizontally. So wherever cosecant is, or secant is undefined, it will still be undefined. And I'll draw my asymptotes in there, which those would be at all of the pi over 2's. Okay, now, right, cosine, our reciprocal of secant, was equal to 1 at 0. So what we need to do is take that value of 1, we're going to multiply it by 3 and add 2. So 1 times 3 is 3 plus 2 is 5. So we're going to be at the point 0, 5. Okay. And then from there, what's going to happen? It's going to go out and up, right? Okay. So now we have for secant our numbers at negative pi over 3 and at positive pi over 3 were 2, right? Because cosine is equal to 1/2 there. Okay. So we take the reciprocal 1/2, we get 2, multiply that by 3 and we get, and add 2 to that and we're at 8. So we're going to be at 8 here and here. So on the other side of the asymptotes then, we're in the negative. Cosine of pi is negative 1, right? Okay. Negative 1 times 3 is, and negative 3 plus 2 is negative 1. So this one's going to be at negative 1, not negative 5. Okay, so make sure you don't make that mistake. Where cosine is negative 1/2, take the reciprocal, we get negative 2. Negative 2 times 3 is negative 6, and negative 6 plus 2 is negative 4. Does everybody understand where I'm getting those numbers from for the 1/2? All right, because those are easy numbers to work with. That's why we're using them, okay? Okay, and then we can continue to draw this graph. I care. Cotangent. All right, so if you want to draw the graph of cotangent then. Now, just like when we drew tangent, we didn't put sine or cosine on there. Also, when we do cotangent, we're not going to put the graph of tangent up there because it'll get very confusing because they cross each other and it doesn't look very good. What's that? No, do not put any other graphs on here. We're just going to graph cotangent here. Okay. Now, Cotangent is cosine over sine. So when sine is equal to 0, we have what? Asymptotes. Okay? So whenever sine equals 0, we have asymptotes here. So at all forms of pi, you want to see me mess with my wife? My wife. Come on. Oh, no, apparently she's not, because it said somebody just logged in. Oh, they probably went to the other one. Hold on. That's my home computer. Oh, no. No, it said somebody just logged in, so I wondered if they. What? Yeah. I do this all the time. I sit at home and I get onto the computer here so that I can work with my documents online. So it's just an app. No, because the reason I know she's on because I shut it down this morning. So either she's on or Micah is. So he was at home sick. So I'll leave him alone right now. Okay. So all right, and I'm recording all this. This is on the video. Okay. So all right now. So for cotangent. When is cotangent equal to 0 then? When is cotangent equal to 0? Because cotangent is cosine over sine, right? So when cosine is 0 and sine is 1, which would be at pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2. Now, cotangent is the reciprocal of tangent, right? Okay. So when tangent is 1, cotangent is 1. Okay, so when is tangent equal to 1? When's tangent equal to 1? At pi over 4. So pi over 4, tangent and cotangent are both equal to 1. Okay. When is tangent equal to negative 1? So at 3 pi over 4, cotangent is negative 1. And so this graph is going to look like, for cotangent, is going to look like this. So it's very similar to tangent, except for it actually goes the other direction. These are ones that are at pi over 4, all of the pi over 4s. Okay. So there's our graph of cotangent. So the period for cotangent would be what? Pi, just like tangent, the period is pi. Okay. The domain, t cannot equal, where are my asymptotes at? Okay. All forms of pi, so pi n. Okay. And how about the range? All real numbers. Now we're going to deal with the most difficult part of transformations, really. Well, one of the difficult parts is horizontal shifts really cause the biggest issue. Being able to draw them correctly is sometimes quite difficult. So you have to be very careful when you do these. Okay, we do have Allie's idea of skipping them. Unfortunately, that's not an option today. So now, you can skip them Saturday if you want, okay? All right, so here's the thing. It's very important that you take your time when you do these and be very precise, because mistakes are easily made. Right? And the first thing we're going to do is we're going to start with, and understand this, I want my asymptotes first. Whenever we're going horizontal, I want those main numbers first. And so when we're talking about secant, cosecant, tangent, or cotangent, the most important things that you're going to put on the graph to start with are the asymptotes. So that's where we're going to begin. Now, let's talk about these letters that these represent. Okay, we have a -4 up there. What does that tell me? Okay, so it's going to be reflected over the x-axis, and it's going to be stretched by a factor of 4. Okay, so all my 1s are going to be 4s. Okay, all right. Now, or -1s, -4s. But what about this t plus pi over 2? What letter does that plus pi over 2 represent? Okay, all right. It represents B. Okay, so that means we're doing a horizontal shift. And in this case, that horizontal shift is going to be to the left by pi over 2. Remember, anything that happens horizontally is always the opposite. So, when I describe this transformation, okay, first of all, we have a horizontal shift pi over 2 to the left. Okay? Because the value of b here, b is equal to negative pi over 2. Because remember, the general form, it's t minus b, not t plus b. Okay? Then we have our vertical reflection. and vertical stretch. Now, the asymptotes. Okay. In cotangent, with a graph of cotangent, all right, so let's label this thing first of all here. So we've got pi over 2, pi, 3 pi over 2, 2 pi, negative pi, negative 2 pi. Okay. Where are the asymptotes at for cotangent? No, for cotangent, they're at every pi, right? Okay, so my asymptotes, where normally they're here, they're at all of these spots, okay? But in this case, I've shifted it to the left pi over 2, so that means that this one's going to end up over here, this one's going to be here, this one's going to be here, here, and here. I know, you can't do that on your paper, okay? All right? So, I moved all my asymptotes to the left. So, here's the thing, okay? Is that all of my numbers then, okay, where did we start? We just started right here between 0 and pi, correct? So I'm going to take all of those values then and then just shift them to the left pi over 2. So what's 0 times negative 4? 0. Okay? So in between my asymptotes, I'm still at 0. So I'm at 0 here, here. Oh, we need a different color. Let's go red. Here, here, there, there. Okay? Now, that's fitting. Okay? So, all my graphs then. Okay, all my other points. Okay? At pi over 4, we had 1. Instead of that spot being 1, it's going to be negative 4, right? Because we're multiplying by negative 4. So, the one here that was going to be here, okay, is now going to be down here at negative 4. Okay, is everybody okay with that? Okay, all right. Rachel, you okay? All right. So what I did is I took my graph, okay, so this would have been here, right? It was there. So when I slide it over here, okay, I have to take the reciprocal and stretch it. So that means it's going to, this is great. Oh, but it won't stretch correctly, but it's going to, you understand what I'm talking about then, okay? All right. So then this one's down here at negative 4, so this one here at pi over 4 now will be at positive 4, and I can draw my graph. So you have to be careful with these, making sure that the asymptote ends up in the right spot, okay? And then work from there. So take one section. Here's what you do, though. Just like what we did. We took one section from that graph, transformed that section, and then we knew everything else looked like that, so all I could do was just repeat it then.